Welcome to this introduction to the 7 steps of Lean. At DAF, we train our employees in the use of the Six Sigma improvement toolkits like Design for Six Sigma for new processes, Lean for waste reduction in existing processes, and Six Sigma for variation reduction in existing processes. This training movie will introduce you to the Lean improvement methodology, addressing how to execute improvement projects according to the 7 steps of Lean. My name is Daniela, and I'm one of the dedicated Six Sigma Black Belts working at DAF. During the next 28 minutes, I will lead you through the 7 steps of Lean. Thank you in advance for your attention. This introduction to Lean is built up around the A3 one-pager document that is used as a standard within DAF. Note that projects reported in any format can be accepted, provided all 7 steps of Lean can be clearly identified. As soon as you face a problem that requires fixing, or you see an opportunity for improvement, use the A3 format right from the start to help you out with your investigation. The A3 format will guide you through the 7 steps of Lean. You will use tools that clarify the reasons that led to your decisions, so there's no need for defending them at a later point in time. Execute and document your work in a structured way so you can take any reader on a trip through your project. For each and every one of us, presenting clear, structured and founded stories is a very useful skill to possess. Step 1 is all about defining the project. A good project definition consists out of addressing all 3 key elements. The business reason. Why is the project important to the business? How will it contribute to the company goals? Use the business reason to sell your project to the company. The more important the project, the more support you'll get. The opportunity statement. Let's start with what it's not. It's not an action statement. It's not a statement that implies a solution, like installing new software or buying new equipment. No, your opportunity statement should always read, increase or decrease something from a current level A to a desired level B. Desired level B could be a company KPI or a specification that needs to be met. When choosing your own target, raise the bar and aim high. That will make you work just a little bit harder. The definition unit of measurement is used to describe what you will be measuring and how. It's also to bound the process you are investigating and to scope what is and is not included in your measurements. Let's take a look at some examples. On-time delivery. The business reason for the project. At least once a week, connectors are supplied to DAF Eindhoven too late, creating severe production disturbances as scheduled trucks cannot be built and production planning is forced to last-minute reschedule the assembly order of trucks. The opportunity statement. Reduce the number of times connectors are delivered too late from once per week to 0. The definition unit of measurement. The number of times connectors from supplier XYZ are supplied too late. We scope the project down by adding the supplier number. Our investigation only focuses on connectors delivered by this specific supplier. In this particular case, it's wise to mention what will count as too late or what is considered to be on time. We define that too late is later than 24 hours before the scheduled assembly in production. So we add this to our definition unit of measurement. PPM reduction. Last month, 12 defective front fenders were supplied, endangering the relationship with our customer DAF Trucks. In the future, this could result in DAF Trucks leaving us to do business with better performing companies. The opportunity statement. Reduce the number of supplied defective front fenders from 12 per month to 0. The definition unit of measurement. the number of supplied defective front fenders with part number ABC. While working on your project, your investigation may reveal that the front fenders are defective because of missing inserts. In that case, you can update your opportunity statement to reduce the number of supplied defective front fenders due to missing inserts from 12 to 0. Your definition unit of measurement will change to the number of supplied defective front fenders with part number ABC with missing inserts. While working on your project some more, your investigation may reveal that the inserts are pressed into a hole of which the inner diameter is too large. The inserts fall out of the hole and this is the reason they are missing. In that case, you can update your opportunity statement to reduce the inner diameter of the insert hole of part ABC from 5.9 to 5.5 millimeters. Your definition unit of measurement changes to the inner diameter measured in millimeters. Feel free to update and change your opportunity statement when needed. Fine-tuning makes you zoom in on the problem you are investigating and increases focus for your team. It provides more focus on where to find a solution to the problem. It kind of makes your problem smaller. A good Lean project is always a team activity. So when you have defined your project, you set up your team. Why is it important to have team members? Why can't you run a good project all on your own? Well, have you ever seen this short movie? When you are looking for one thing, you might just miss another. We need more people to focus on more things than just one. We can't see everything ourselves. Try this exercise with your team, just for fun. You can find it on YouTube, The Monkey Business Illusion. Your core team should always include your champion, which is your project supporter, the process designer, he or she knows how it should work, the process operator, this person knows how it actually works, the process owner, for when you want to make changes to the process, the customer, to find out what is of value to him or her and what is not, and the supplier, when the supplier is supplying something you use as input for your process. Feel free to add more supporting team members when necessary, because remember, the more eyes, the better. Step 2 is the start of any project, mapping your current process. And to find out what your process looks like, you go to the Gemba, the actual place of work. Never assume to know, sitting behind your desk, what your Gemba looks like. Go and see for yourself. It may have changed just a bit more than you expected. And when you are there, talk to the most important person involved in your process, the operator. Doing a Lean project is all about identifying waste, non-value adding activities. So when you go to your Gemba, see if you can identify one of the following types of waste. Transportation. Moving stuff around, like moving stock from warehouse to warehouse. Inventory. Having too much of it or having things in stock that you don't need at all. Motion. The motion of people. Walking, reaching out. Waiting. Having to wait for goods to be delivered or information to be supplied. Overproduction. Quantity-wise, producing more than needed or when it's not needed at all. Overprocessing. Doing more than what's required or adding more process steps than needed. Defects. Making errors or defective parts resulting in rework. And wasted skills. Not using people to their full potential is a waste as well. Use the acronym Tim Woods to help you remember these different types of waste. When you know what your process is all about, it's time to visualize your process by mapping it. It's a clear and simple way to communicate the process to your team and will help identify areas for improvement. Use the map that best visualizes your process. A process flow diagram. This diagram maps your process step by step. It can be set up using fancy software, but using simple post-its is just as easy. Color coding can be used to distinct value-added and non-value-added steps. A swim lane. This tool maps your process step by step and assigns each step to the persons or the departments involved. This map is advisable to use when more people or departments are involved in your process. Use a whiteboard and post-its so you can easily rearrange the steps by simply moving the post-its around. A spaghetti diagram. This is a simple but very effective visualization of the flow of people, materials, or information. In this particular picture, the walking routes to wash a car are visualized. Just use paper and a pen. The standard work combination table gives a visual overview of the time associated with each step in your process. It's used to visualize the total cycle time of a process and where best to look for improvements. With colors, you can highlight machine time, operator time, waiting time, etc. The work balance board is a tool to balance out the work between operators. If the sum of the tasks is below the TACT, you have enough time to meet customer demand. If the sum of the tasks is above the line, you need help. Investigate if you have non-value-adding activities and eliminate these first. Then check if you can rebalance the work between the operators in order to meet the TACT. Visualization of your process helps you identify the problem and makes it easier to define on how to solve it. It's also the easiest way to communicate to others what your process looks like. And we all know that a picture says more than 1,000 words. And then to round up step 2, add a summary of your findings by adding a key observation. Looking at your process, what sticks out most? And add your key performance indicators. The one-pager contains a pre-filled out list of KPIs you can use, but feel free to remove them and replace them by your own. Add all indicators that quantify the performance of your current process, the current cost price, current lead time, current PPM level, etc. Immediate countermeasures are about protecting the customer and stopping the bleeding. You have a problem and you don't know the root cause to this problem yet, but nevertheless you have to fix it right away. Immediate countermeasures are simple, low cost and low risk. A well-known measure is the temporary introduction of a 100% inspection solving the immediate problem for the customer. An immediate countermeasure should never be the final solution. It is only to buy you time to find the root cause to your problem. The first step within step 4 is identifying possible causes. A visual brainstorm tool to use here is the fishbone diagram, also called a cause and effect diagram or an Ishikawa. Get your team together in a room and use this tool to identify all possible causes in the 6 categories that are commonly used: people, method, measurement, machine, environment, and materials. Then, with your team, collectively vote to identify the most likely cause driving your problem. Consider making the fishbone diagram on a whiteboard or take a large piece of paper and put that on the wall. Make sure that everyone in your team is involved. There are no stupid ideas. It's amazing how many causes a team can identify, even if you spend just half an hour. Let's take a look at some examples. Cost price too high. Reasons could be complicated part design, expensive packaging, low minimum order quantity, high transport costs. Lead time too long. Causes could be unavailability of raw materials, shipment by boat, specialty parts, or order sent out too late. PPM level too high. Could be due to wrong part labels or the mix-up of left and right parts. The next step is to identify the root cause. For that we make use of the 5x tool. It starts at the top with the voted most likely cause from the fishbone diagram. It's a very simple tool. Children are very good at this. They will ask you why over and over again. Let's take a look at an example based on one of the previous examples, lead time too long, with the most likely cause being order sent out too late. Why is the order sent out too late? Because the notification came too late. Why did the notification come too late? Because the system didn't update. Why did the system not update? Because the computer was turned off. Why was the computer turned off? Because the plug was disconnected. Why was the plug disconnected? Because someone tripped over the cord. This is the root cause to your problem. And the problem to fix is that you should prevent people from tripping over the cord. And then, to round up your analysis, add a summary of your findings. What root cause did you find? Now it's time to start thinking about solutions. Have a brainstorm session. Get your team together and generate as many ideas as possible. And note, criticism is not allowed. A team member you make fun of once is not very likely to participate again. Consider using the fishbone diagram to give structure to the brainstorm using the 6 different categories. When it comes to brainstorming, the more ideas the better. And get everyone to speak up, make sure all your team members are involved. Within Lean, there are many ways to improve processes. We will highlight a few possibilities now, just to give you an idea. 5S is all about organizing workspaces to create a smooth flow within a clean environment. 5S would be a perfect tool to use to solve the problem of tripping over the cord. Sort. Only keep what you need and throw the rest out. Straighten. Organize what you have left. Shine or sweep. We clean up. Then we standardize by creating guidelines. And we sustain to ensure the new environment remains organized, orderly and clean. 5S is without a doubt a team activity, and not just to avoid throwing things out that your colleagues still might need. By collectively looking for ways to improve, you get to know your colleagues and their processes, learning from each other and generating mutual understanding. JIT. Just in time. What you need, how much you need, exactly when you need it. A way to achieve this is by introducing one-piece flow. Everything is within reach and done step by step, one part at a time. Pull systems. We only make what is needed by the customer, therefore minimizing waste. Another just-in-time solution is best point of use. Materials are located precisely there where they are needed, easily accessible and easy to reach. Visual management. Another example on how to improve is by using visual methods to convey information and prevent mistakes. For example, by using shadow boards and introducing color coding, or by adding markings on the floor, or maybe even as simple as this. Poka-yoke. Because human errors are inevitable, we aim to build in quality. We aim to prevent mistakes from occurring by mistake-proofing our processes so it cannot go wrong. By implementing Poka-yoke designs or Poka-yoke processes. Poka-yoke solutions are always preferred, either detecting the problem close to where the problem occurs or to prevent the problem from happening at all. SMET, single minute exchange of die. No need to address this in detail. SMET is all about reducing setup times. The best known example is a pit stop during a Formula 1 race. Within 2 seconds the car is on its way again. But it didn't always go that fast. In the 1950s, this process took 67 seconds. And once again, add a summary of your findings. What solutions did you come up with to solve your problem? And which one did you choose and why? When introducing a new process, new risks are introduced as well. Together with the team, think about the risks involved and find ways to mitigate them. There are always risks involved when changing a process. Changing your work location. Improvising when not having the proper tools like a workbench. Or when you introduce a new type of scaffolding. Let's take a look at some other examples of new risks we can introduce when changing a process. Transferring to a cheaper supplier could result in having longer delivery times, or having higher minimum order quantities. Or maybe the supplier that we're transferring to has a very poor financial situation that we need to address. When changing to transport by air instead of the road, we could find that the packaging is not suitable for transport by air. Or maybe customs activities turn out to be too complicated. Or the additional costs are too high. Changing the design of a part could result in higher costs for production, or a shorter lifetime of the part. Or maybe you want to change the design, but there's simply not enough engineering capacity to do so. When introducing a checklist to make sure that things are not forgotten, it could be that your checklist is incomplete. Or when you have a complete checklist, that your checklist is not being used. Or people want to use your checklist, but they cannot find it when they need it. The risk evaluation checklist is a separate list you add to step 4 on the one-pager. In this list, you mention all the risks you have identified and how you are going to mitigate these risks. The risk evaluation checklist is the last step to take in step 4. At the end of step 4, your storyline should not just contain an overview of conclusions and decisions. It should include how you came to your conclusions and why you made certain decisions. This background is essential to add at step 4. And yes, this becomes quite a challenge when documenting your project when it's already finished. So I cannot emphasize enough to use the A3 one-pager right from the start of your project. Step 5 contains the implementation plan. What needs to be done by who, by when. Always assign the action to an individual, a team member, so not a group or department, to avoid that no one feels responsible and the action is not taken. Do not forget to also close all actions related to your risk mitigation. In line with step 2, we also visualize the new process by mapping it. Use the map that best visualizes the new process. Ideally the same one you used at step 2, so the difference, the improvement, is easy to see. Like less process steps. A faster process. A better work balance. A more efficient flow. Like you did at step 2, add a summary of your findings by adding a key observation. Looking at your new process, what sticks out most? The performance indicators you chose to use at step 2 are automatically copied to step 6. Add the new value of your key performance indicators to quantify the performance of your new process, your new cost price, your new lead time, new PPM level, etc. In your opportunity statement, you mentioned your desired level B. Do not feel bad if you do not succeed in meeting your target. You may have set the bar too high. Yet, if you have far exceeded your target, you may have set the bar too low. Communicate your final achieved level B at step 1 on your one-pager. The final step in any lean project is to ensure that all implemented changes will remain implemented. How will you sustain the new process? What if operators change because they leave the company? Well, the first step is to get your team involved right from the start of the project. Get your team's buy-in for each decision that's made. And introduce Poka-Yoke solutions so things cannot go wrong anymore. Build in quality and mistake-proof your new process. And standardize the work. Introduce clear work instructions that lay the foundation for continuous improvement. So rounding up this training, we took you through the 7 steps of Lean. Defining the project using the 3 key elements. Mapping the current process by going to the Gemba and visualizing it using process maps. A temporary solution to immediately stop the bleeding for the customer. The analysis phase, where we looked for causes and possible solutions and avoiding new risks. Implementing our changes. Then mapping the new process, ideally using the same process map you did at step 2. And making sure your new process is sustained, so even when you leave, your new process remains. Clear, structured, and founded. If indeed you chose the right project to execute, your champion agreed to support you while working on it. So when you possibly hit a roadblock, contact your champion to help remove it. That is what he or she is for. In case you need help from DAF while working on your project, contact either your assigned commodity manager or your supplier quality assurance manager. And please do not forget, as soon as you face a problem that requires fixing or you see an opportunity for improvement, use the A3 right from the start. I wish you all the best and good luck with your projects.